In reduction oxidation reactions, we have a reduction and an oxidation. And sometimes we divide these out from the overall reaction and we write them as two half reactions. So let's take this overall reduction oxidation reaction, chlorine gas plus sodium iodide going to iodine plus sodium chloride. Here, if we want to identify the two things that are being reduced and oxidized, I should do the oxidation states of all of the elements in the reaction. Give myself a little bit more space there. Chlorine's oxidation state as an element is 0. Similarly, iodine as an element is 0. Sodium, an alkali metal, is always going to be +1, and the halogen I here is its usual oxidation state of -1 when in compound. And similarly, the sodium here is going to be +1, and the chlorine is going to be -1. So we can see that the chlorine has gone from 0 to -1, 0 to -1, and the iodine has gone from -1 to 0. And that here we can see it's gone from -1 to 0. So I can write these as the reduction and the oxidation. To figure out which one's which, remember, reduction is the one where the oxidation number is decreased. So if I went from 0 to -1, that is a reduction in oxidation number. And the oxidation is the one where the oxidation number is increased. So if I went from -1 to 0, that's the oxidation. Now we have to remember this is a little bit backwards because electrons were made to be negative, so it kind of messes with the way we think about it a little bit. But if I go from 0 to -1, that means I gain 1 electron, or 1 negative. And if I go from -1 to 0, that means I lose 1 electron. So remember, reductions are the ones that gain electrons, and oxidations are the ones that lose electrons. When I write the half reaction, I'm going to put the actual number of lost or gained electrons straight into the reduction. So this is how I'm going to do that. For example here, chlorine is going to 2 chlorines. So because it's diatomic, that means that I have 2 elements. So each one of those elements is going to gain 1 electron. But since I have 2 and 2, that means that I'm going to gain 2 electrons in this process. 1 per atom, 2 atoms, so 2 electrons. Alternatively, going from -1 to 0, you must have given up your minus charge, given up your electron. Each, again, atom is losing 1 electron per atom. So if I have 2 atoms, that means I'm giving away 2 electrons. And we can see how these are complementary processes. This one absorbed the 2 electrons that were given off from this one. So the electrons went from the oxidation process to be supplied for the reduction process. Just one more quick thing here then. Since chlorine is the one that's getting reduced in the reduction, we call it the oxidizing agent, meaning that it oxidized iodine. Alternatively, iodine, which gets oxidized, then what did the iodine do? It was a reducing agent. It reduced the opposite. It reduced the chlorine. So those are your half reactions. I'm going to do another video in a second here where I just do a little bit more practice writing these out. But we can see that we can write it as the reduction and the oxidation separately, and we can see how we can make sure that our number of electrons being produced and our number of electrons being absorbed should be the same, and we'll use that when we learn how to balance these chemical reactions.